Hi everyone, it's Miss Letty here, and I hope you're all having a great day. So today I want to talk about a specific topic in the subject of physics, which is kinematics. Now, kinematics is the study of movement and motion. So today we're going to talk about the different mathematical expressions or formulas that we can use to sort of recreate what we know happens in real life. Now, in kinematics, we're going to be talking about a couple of important concepts, which are distance, displacement, speed, velocity, and acceleration. So let's talk a little bit about them. When we're talking about displacement, this means this is a vector that corresponds to the difference between the final and the initial points, while your distance is the total amount that was traveled, all right? When we have speed and velocity, the difference is really clear. Speed is a scalar quantity that obviously only has a magnitude. Therefore, it is, for example, when I say 5 meters per second. And when we're talking about velocity, that is a vector that has both magnitude and direction. Therefore, the difference would be that in a velocity, I would say 5 meters per second north, or 5 meters per second at 270 degrees. All right. Then we have acceleration. Acceleration is the change or the difference in velocity over a specific amount of time. So these are the important concepts that we're going to be using in kinematics. So let's get started, okay? First, let's talk about horizontal movement. When we're talking about horizontal movement, we obviously are going to have our velocity, our acceleration, our time, and a distance or displacement that we're going to be traveling. Therefore, the formulas that you see right now on the screen are the formulas that we can use. They're mathematical expressions that represent or recreate our physical phenomena that we have when we're talking specifically about movement. Now, all of these formulas work in a very similar way, and they're all going to get us the same results. What is the difference between them? The difference is the information that I have and the information that I am looking for, okay? Therefore, if, for example, I am looking for the initial velocity in a specific case, and I already know the final velocity, for example, the acceleration and the time, therefore I can use this very first formula to be able to isolate for my initial velocity. All right? Same goes for every single formula that we have here. And as I said, they're all going to get us the same result. It's just a matter of what information I have and what information I want. Sometimes we need more information. Therefore, we have to use two formulas. One to get one piece of information, and with that piece of information, we can get a different piece of information. All right. Now, in horizontal movement and in vertical movement as well, we can have two different sort of types. We have, first and foremost, we have our uniform motion, which is basically when we are moving at a constant velocity. What does that mean? That means that my acceleration is going to be 0, okay? So if I'm moving at 2 meters per second, I am also moving at 2 meters per second after a while, and my final velocity is also going to be 2 meters per second, all right? Therefore, in that case, all of these formulas get a little bit simpler, but it is also important to remember that in this particular case, we can use a rule of 3. We can only use this in this specific case because our velocity is going to stay the same always. All right? So when we're trying to do this, these formulas, when we are in uniform motion, then most of them are going to be canceling out. What does that mean? That means that if my acceleration is 0, then this right here is going to cancel out, which leaves me with final velocity equals initial velocity, which I already knew. All right? Over here as well, in the second formula, I'm going to cancel out this second term because my acceleration is 0. All right? Now, the rest of the terms, so this right here, or the rest of the formula, sorry, are going to be a little bit more useful, all right? So if we take, for example, this formula right here and isolate for our velocity, we're definitely going to end up getting our velocity equals our change in position over time, okay? Which this right here is the general definition for our velocity. All right. So this right here, in a nutshell, this right here would be the formula that we're going to be using for our uniform motion. All right. All right. So in conclusion, in terms of our uniform motion, we can use this formula right here. We can also use this formula over here for our uniform motion. It's basically the same thing. But this one's going to be the one that is going to help out the most, along with some rules of 3. Okay? That is for when we have uniform motion, when we have a constant velocity. Now, what happens when I don't have a constant velocity? Then what that means is that I have an acceleration that is going to be constant. Therefore, motion with constant acceleration. All right? In this case, we can use any of these formulas to be able to identify what things we want to calculate, what things we already have. All right? Other than that, it is basically pure math of trying to isolate and play around a little bit with the formulas to get what we want, right? Now, something really important is our signs. Our velocity is positive when we are moving forward or to the right or up, okay? In this horizontal section, we're obviously not going to go up, but just leaving this information for the next part, which is a vertical motion. Our velocity is going to be positive in those cases. Therefore, it is going to be negative when we're going backwards or to the left. Right? That is an important piece of information because it is also going to be used for identifying the sign of our acceleration. When we're moving forward and we are speeding up, our acceleration is positive. When we're moving forward and we are slowing down, our acceleration is negative. All right? If we are going the other way around, if we're going backwards and we are speeding up, then our acceleration is also negative along with our velocity. And if I'm going backwards and I am slowing down, my acceleration is positive. One easy way to remember this is whenever I have the same sign, so a positive velocity and a positive acceleration, or I have a negative velocity and a negative acceleration, then this right here means that I am speeding up. All right. If I have opposite signs, then that means I am slowing down. All right. So that's in terms of our horizontal motion. Now let's talk a little bit about our vertical motion. Our vertical motion, it's basically the same thing as our horizontal motion. If you notice, the formulas are very much alike. They're basically the same. The only difference to this is that instead of having a delta x, which is our displacement, we have a height. All right, same thing. It is sort of the pathway that we have traveled in our specific cases. Now, the other thing that changes is the acceleration. In our vertical case, our acceleration is now going to become our gravity. Okay, our gravity, we're going to take it as negative 9.81, and that's meters per second squared. All right, so basically it's the same thing as our horizontal motion. We're just plugging in information into our different formulas and considering what we want to obtain at the very end. All right, now in vertical motion, we can have two sort of different types as well. We can have a vertical launch and a free fall. In vertical launch, that is basically when, for example, I throw something up in the air and it comes straight back to the same position. When I do that, I'm throwing it up at a specific velocity here, and I am coming back at the same amount of velocity, but completely opposite. For example, if I threw it at 20 meters per second, then my final velocity is negative 20 meters per second. All right. Now, there's another piece of information that is going to help out a lot, which is that at the very top, so at the very top of our pathway, our velocity is always going to be 0. Always. Okay? This means that with that information, with this information right here, we can get a lot of different answers based on the information that is given to us from specific problems. All right? The important part about this is to remember to only use it when we are trying to get our path halfway through or at our highest point. Okay? Now, another thing that's really important is to remember what we were just talking about our signs. Our velocity during this pathway is positive. Our velocity in this pathway is negative and positive, right? Nonetheless, my gravity or my acceleration is always going to be negative. So we can practice a little bit of what we just talked about. If we have opposite signs, then that means that I am slowing down. So while I'm going up, I'm slowing down. If you notice, we started at 20 and we ended up at 0. Okay? And in the second part, I have a negative velocity and a negative acceleration. Therefore, I am speeding up. If you notice, we're going from 0 to 20. Okay? The sign is just telling us which direction we're going to. All right? And finally, we have our free fall. Our free fall is basically when we have an object that is being dropped downward. In this case, our initial velocity is always going to be 0 meters per second. And another thing that is really important is our height in this case is going to be negative. This is because our reference point is starting up here and I'm going downwards. Therefore, my height is negative. All right. Also, since I am going downwards, then my velocity is also going to be negative. My acceleration is also negative, which is my gravity. All right. So it's important to, in these problems, try to see the big picture of what is changing. Am I changing the position? Am I increasing my position? Am I decreasing my position? Which has a direct impact on my velocity. So if I'm increasing my position, then that means my velocity is positive. I am moving forward or up. If I'm decreasing my position, then that means I'm going backwards or down, which means my velocity is going to be negative. All right, so it's important to kind of try to look at every single piece of information and how they are affected by each other, right? Mathematically, what we have to remember is that these formulas right here are helping us recreate our physical phenomena or our physics phenomena, and we are trying to obtain more information based on information that is already given to us. All right. So I hope you liked this video. I hope it was helpful, and I hope you have a very nice day, and I'll see you next time. Bye-bye.